Hi students, this is Jayapai speaking about module 3, okay, that is all about fuels and solar energy. Let us first see something about fuels. You all know fuel is a source of energy. This word is not very unfamiliar to you all. But if you are asked to define exactly what is fuel, what is a chemical fuel, in that case we need to think a little bit. Fuel is nothing but a combustible substance. Then we start defining it as fuel is a combustible substance which when burnt in air or oxygen produces significant amount of energy in the form of heat and light, and this energy can be utilized not only for household purposes but also for industrial purposes. So that is somewhat a complete definition we can say. Is a fuel is a combustible substance which when burnt in adequate quantity of air or oxygen produces a large amount of heat, in a large amount of energy in the form of heat and light, and that energy can be utilized for domestic purposes as well as industrial purposes. Most of the chemical fuels, they are hydrocarbon fuels. Hydrocarbon means they are made up of carbon and hydrogen. The elements present in hydrocarbon fuels are carbon and hydrogen. When burnt in air or oxygen, the carbon and hydrogen present in the fuel are respectively getting converted into carbon dioxide and steam. So carbon present in the fuel is converted into carbon dioxide, hydrogen is converted into steam. Steam is nothing but water in the vapor form. The combustion of fuel is an exothermic reaction. Any process where heat energy is released, that is called a exothermic process, that you studied in lower classes, that is exothermic reaction and endothermic reaction. A reaction in which heat energy is released, exothermic. The reaction in which heat energy is absorbed is endothermic. Points to be remembered: fuel is a source of energy. Chemical fuel is a combustible substance. It produces a sufficient quantity of air or a sufficient quantity of energy in the form of heat and light when burnt in a adequate supply of air or oxygen. The energy what we are getting from the fuel we can make use of for household purposes as well as on a large scale, that is for industrial applications. And chemical fuels invariably contain carbon and hydrogen as major elements. These elements get converted into carbon dioxide and steam when burnt in air or oxygen. Moving on, examples for fuels. We can give large number of examples here. Some of the familiar examples which you have already studied and which you have come across in your daily life: coal, natural gas, petroleum, charcoal, coke, LPG, CNG, that is compressed natural gas. LPG is liquefied petroleum gas. Liquefied petroleum gas is the one which we are using in our houses, that is for cooking purpose, and butane is the major component present. Compressed natural gas, the major component is methane. Biogas is there, water gas, carbon monoxide and hydrogen, producer gas, carbon monoxide and nitrogen, fuel gas, petrol, diesel, kerosene, etc., etc. Classification of fuels. Fuels can be broadly classified into primary fuels and secondary fuels. Primary fuels are naturally occurring, and they don't require any special treatment before utilization. They act as fuels in the way they are available in nature. Whereas secondary fuels, they are man-made or synthetic fuels. They are subjected to special kind of treatments in order to alter their chemical composition and also the chemical composition and also calorific value. Primary fuels have low calorific value, their burning efficiency is comparatively less, whereas secondary fuels have high calorific value, burning efficiency is quite good. Now primary fuels can be further classified into non-renewable and renewable sources. Non-renewable energy sources, under that you have three types again, that is coal, petroleum and natural gas. About non-renewable energy sources, they are also called fossil fuels. You might have heard enough about that, because for the time being we have abundant quantity of these fuels, we can say, on which we are heavily dependent on. But these fuels, the sources, they are very limited in nature, and they are depleting in nature. They keep depleting in nature, and in the near future we may run out of the sources of all these fuels. But you have another alternative sources, that is renewable energy sources. Under that you have solar energy, geothermal energy, wind energy, biomass, hydrothermal, etc. All these fuels, they are actually renewable energy sources. That means how much ever you use, it is still there in nature. You can use it again and again. It is something like that. It is never ending. It is inexhaustible, abundantly available. But it is quite disheartening to say that even though these kinds of fuels are, energy resources are available in nature in a large quantity, even then to that extent this energy is not being used by mankind. Next, secondary fuels, they are classified into three types. Again, they are classified into three types, that is coke, then fuel gas, then oil. Then man-made synthetic calorific value is high. Same thing it is being told in sentences. Classification of fuels. Chemical fuels are broadly classified into solid fuels, liquid fuels and gaseous fuels, depending upon the physical states in which they are existing in the nature. They are further classified as primary and secondary fuels. Primary fuel is the one which exists in nature, and it can be utilized as a fuel in the form it is available in nature. They do not require any treatment before utilization. And examples are all quite familiar: wood, coal, petroleum and natural gas. Secondary fuels are those, they are obtained from or they are derived from primary fuels. Secondary fuels have high calorific value. Their burning efficiency is quite good. Examples are charcoal, coke, petrol, diesel, kerosene, synthetic petrol, producer gas, water gas, coal gas, biogas, LPG. All these come under secondary fuels. Now the same thing it is being given in the form of a table. Solid, liquid, gas, these are the physical states in which fuels are classified. Then again, solid means in that you have primary fuels, that is wood and coal, and secondary fuels charcoal and coke. Liquid, petroleum, you can say primary fuel, and secondary fuels petrol, diesel, kerosene. And petrol, diesel, kerosene, everything it is obtained from petroleum. It's a crude oil. Gas, it's the natural gas which is available when petroleum is crude oil is brought to the surface by drilling wells. Then this gas, some gas, natural gas gushes out from the earth's from underneath the earth. So that from that natural gas you can subject it to various treatments, and you can convert it into LPG, CNG, water gas, producer gas, etc. They all come under synthetic fuels or man-made fuels, but they have high calorific value. Now in this chapter you are going to have a clear understanding between three definitions, that is calorific value of a fuel. First one, it is defined as how much amount of energy is released when unit quantity of the fuel is burnt completely in air or oxygen. I repeat, it is how much amount of energy that is released when unit quantity of the fuel is burnt completely in air or oxygen. For example, if 1 gram of any fuel is burnt completely in air or oxygen, what is the amount of energy released? If you determine it, then that is its calorific value. Performance of the fuel is expressed in terms of the calorific value. If the fuel releases more energy when unit quantity of the fuel is burnt, then that fuel is considered to perform well. Its burning efficiency is considered to be good. The calorific value is normally expressed in joules per kg for solid fuels. When 1 kg of the fuel is burnt, how much energy is released in joules? For gaseous and liquid fuels, it is the same is expressed in joules per meter cube. Gross calorific value or higher calorific value of a fuel. It definition is somewhat similar to calorific value, only the last part of the definition needs to be understood thoroughly. GCV or HCV, HCV is higher calorific value of a fuel. It is defined as the amount of heat energy released when unit quantity of the fuel is burnt completely in air or oxygen and combustion products are cooled to room temperature. Combustion products are cooled to room temperature. Means combustion products means when any hydrocarbon fuel is burnt, combustion products are carbon dioxide and steam. When combustion products are cooled, carbon dioxide being a gas that escapes, steam when cooled it gets condensed into water. When steam gets condensed into water, it releases some amount of heat and that heat is called latent heat of steam. Latent heat of steam is nothing but the amount of heat energy released when unit quantity of the steam means 1 kg of the steam is allowed to undergo condensation. Now GCV includes latent heat of steam. Since we are not allowing the products to escape, since we are cooling the products of the combustion of the fuel, we are getting that extra amount of heat due to the condensation of steam, which is latent heat of steam. Hence we conclude by saying that GCV includes latent heat of steam. So GCV is nothing but calorific value plus latent heat of steam. Means what amount of energy is released when unit quantity of the fuel is burnt plus what amount of energy is released due to the condensation of steam. Put together is GCV. Okay. Moving on to the next, that is net calorific value or lower calorific value of a fuel. It is definition again same. It is the amount of heat energy released when unit quantity of the fuel is burnt completely in air or oxygen. That is nothing but calorific value. And products of combustion are released to the atmosphere. They are let off into the atmosphere. As a result, NCV does not include latent heat of steam. Since products are completely released into the atmosphere, you don't get steam. So you don't get condensation, don't get latent heat of steam due to the condensation of steam. Therefore, NCV does not include latent heat of steam. So put together, finally if you want to put GCV and NCV in terms of mathematical expressions, then NCV you can write it as GCV minus latent heat of steam. From GCV, if you subtract latent heat of steam, you get NCV. To NCV, if you add latent heat of steam, then it is GCV. So GCV is always greater than NCV. As far as these basic concepts are concerned, you need to remember the definition for fuel. You need to remember what are the elements present in a fuel, what are the products of combustion of the fuel, what is calorific value of a fuel, then definitions of gross calorific value and net calorific value. The major difference between gross and net calorific value, in gross calorific value, in addition to the calorific value of the fuel, you are getting extra heat due to the condensation of steam. Whereas in net calorific value, only calorific value it is, because it is not it doesn't include a latent heat of steam. Here we are releasing the products into the atmosphere. I think I'll conclude here, and rest of the concepts will be discussed in the upcoming video, and in the next video I'll be explaining to you all it is something about how to determine the calorific value of a solid or a liquid fuel using bomb calorimeter. Thank you.